Hello everyone, this is going to be section 5.1 part 2. So we have some examples of Riemann sums that we can do with certain functions, and we're going to calculate at least the left and right Riemann sum to have some examples. So first, let's go ahead and start with this function. So we're going to have f of x is going to be x plus 1, and we're going to go on the interval 1 to 6, and we're gonna do phi interval partition. So that means that we're gonna go one by one. So if we check that partition going from 1 to 6, notice that essentially we have 2, 3, 4, and 5, and that's gonna give me the 5 intervals that I can use. Because I'm going to be doing different Riemann sums, then we're going to use different points for this, but this is the partition that we're going to use. So now the delta x is going to be calculated as b minus a over n. So in this case, it's going to be 6 minus 1 over 5, since n is equals 5 as well. Notice that that's going to also give me the length of the interval, which is going to be 1. And so if we're going to do the left Riemann sum and the right Riemann sum, we're pretty much going to have to worry only here about the point that we're going to use for the height. So in the case of the right Riemann sum, let me use another color. So in the left Riemann sum, we're going to use 1, 2, 3, 4, and 5 to give the height of the intervals. And notice that I'm not even graphing the function, but I can know what intervals I'm going to use. And so with that into account, I can say, well, I'm going to do f1 times 1 from the delta x plus f of 2 times 1 from the delta x, f of 3 times 1, f of 4 times 1, and f of 5. Now at this point, of course, then I need to actually plug in the function. So f of 1 is going to be 2, f of 2 is going to be 3, f of 3 is going to be 4, f of 4 is going to be 5, and f of 5 is going to be 6. So this is overall the sum of the left Riemann sum with this. Adding this, we have 15, 18, 20. Now by the right Riemann sum, we're going to use different points. Since we're going to start from the right side, we're going to use 2, 3, 4, 5, and 6. And so given those points, we have f of 2 times 1, f of 3 times 1, f of 4 times 1, f of 5 times 1, and f of 6 times 1. Now, similarly as before, we just need to plug in the function. So we have 3, 4, plus 5, plus 6, plus 7. And so this is going to be 10, 20, 25. So that's going to be the approximation for this particular case. Now let's move on to the second example, where we're going to have the function b equals f of x equals 1 over x. We're going to use the interval 1 to 5, and we're going to go with n equals 4. So at this point, the first thing that we do is calculate delta x, which is 5 minus 1 over 4. Again, this is 4 over 4, this is 1. And so we're going to be doing pretty much the same thing that we did before. From 1, we go to 2, we get to 3, to 4, and then we end up on 5. So we have 4 partitions here. Now, then we go for the right Riemann sum or left Riemann sum. So in this case, let's do first the right Riemann sum. And we're going to pick those points for the right Riemann sum. So the right Riemann sum is going to be all the sum of the f of xi times the delta x, and this is going to be for I equals 1 to 4. So we're going to have f of x1 times delta x, f of x2 times delta x, f of x3 times delta x, and f of x4 times delta x. And notice that in this case, we're going to be calling this x0, x1, x2, x3, x4. So you get a little bit of idea what are we doing with the notation. But in reality, this just transforms into f of 2 times 1 plus f of 3 times 1 plus f of 4 times 1 plus f of 5 times 1. And now this is going to be 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. And that will be the right Riemann sum in this case. A similar situation will be if we consider the left Riemann sum. But now for the left Riemann sum, we need to change the values. Then now we start from 1, 2, 3, and 4. This is going to be the values that we're going to use. So we're going to go from x0, x1, x2, and x3. Those are going to be the values that we're going to consider. And so in terms of notation, that will be 0 to 3 of f of xi delta x. And it will be f of 1 plus f of 2 plus f of 3 plus f of 4. So 1 plus 1 half plus 1 over 3 plus 1 over 4. That'll be my Riemann sum, my left and right Riemann sum for this function f of x equals 1 over x. Now let's see a couple more of examples of Riemann sums. So for the following function, we're just going to use a partition with 2 elements, and I'm going to work on the interval 2 to 4. Now, for this particular one, we're going to use the middle point Riemann sum. So if we find the delta x, which is going to be b minus a over n, we're going to get that this is 4 minus 2 divided by 2. This is 2 divided by 2, and this is 1. So this means again that we're going to have 2 to 3 to 4, and that's going to be pretty much our partition. Okay. However, because we want to use the middle Riemann sum or the midpoint Riemann sum, then we want to use this point, the middle point, 2.5 and 3.5. And then in this Riemann sum, what we're going to get is f of 2.5 times 1 plus f of 3.5.1. Now, don't be confused. In these cases, we're getting examples where the delta x is 1, and so we don't need to make big calculations here. But not all the times you're going to get that delta x is 1. You might get different results here, and that's going to influence more what you get for the Riemann sum. In this case, then we get 2.5 squared minus 1 plus 3.5 squared minus 1 again here. And so at the end, this is going to be 2.5 squared plus 3.5 squared minus 2. Okay. All right, let's do another example more with the last function. This is going to be the function f of x equals 4 minus x, and we have from the intervals minus 1 to 4, and Instead, let's not make it n equals 5, since that's going to produce pretty much the same, but let's use n equals 10. So if we do that, now we're going to get a variation of the delta. So the delta x here is going to be b minus a over n, and it's going to be 4 minus 1 over 10. So this is going to be 5 over 10. This is going to be 1/2 or 0.5. So this is a much larger partition. And if we go from -1 up to 4, but we're going to go in 0.5s, then we're going to get that minus 0.5, 0, 0.5, 1, 1.5, 2, 2.5, 3, and we'll run out of space here. Then we get 3.5, and then finally 4. So as you can see, we have all these 10 intervals, and then now it depends of whatever we're going to use. If we're going to use left Riemann sum, or we're going to use right Riemann sum, or if we're going for the mid Riemann sum. Okay, so let's just do here in this particular case the left Riemann sum. So we're going to use these values. Now on here, the whole sum will be minus f of minus 1 times 0.5, because this time the delta x actually is a different number than 1. F of minus 0.5 times 0.5. Or you know what? Let me use, instead of 0.5, let me use 1/2. So this is more elegant. Plus f of 0, 1/2, plus f of 1, 1/2. Well, actually 0.5. 0.5 plus f of 1, 1/2. f of 1.5, 1/2, plus f of 2, 1/2, f of 2.5, 1/2, f of 3, 1/2, f of 3.5, 1/2, and f of 4, 1/2. Okay, so as you can see, pretty long, and sometimes that's why we don't make big partitions, although you might not get so much accurate approximations unless you're doing this. But that's the overall idea of obtaining one of the Riemann sums. Then you plug, of course, in the function whatever you got. So for example, -1 is going to produce a 5, right? So 5 times 1/2, and if I block minus 0.5 here, I'm gonna get 4.5, 1/2. In 0, I'm gonna get 4 times 1/2. In 0.5, I'm going to get 3.5, 1/2. Then 3 times 1/2, then 2.5, 1/2, and so on. And so this accounts for the approximation that we'll get doing the Riemann sum. Then after that, you add all the values, and the decimal numbers that you might obtain will mean our approximation to what the area under the curve is. Notice that I'm not doing here the function, but of course there's a function on top, So if I'm going 0, and this is actually going from -1. So -1, 1, 2, 3, 4. If I'm having the function 4 minus x, notice that that's gonna start high here. It's gonna start here on 5, then it crosses 4, and it's 0 here. So you have this. Well, this is not a. It's not a good draw. You have the equation of the line coming on here. It's supposed to cross as 4. Okay, now I lost my whole line. Okay, so something more or less like this. So we're really trying to find what this area under the curve is, and we're doing it with this approximation. And so we'll start getting the image of each of these values, and we'll start getting things like this. Okay. So this is pretty much what we're getting with the left Riemann sum. Okay, we'll see a little bit more of this in detail to what happens if we have stuff that is under the x-axis in section 5.2.